Hello, my students. I want to give you a brief about the types of MOSFETs that we will be using in class number 1. So MOSFETs can be classified into two types. As we know, we have N-channel MOSFET, and we have here, as you know, P-channel P MOSFET, or we can say it N MOSFET, and we have here P MOSFET. Okay, now those two types also can be classified into two types here. We have enhancement, and here we have the second type is called depletion. The same thing for the P type. It can be classified into two types. The first one is enhancement, and the second type is depletion. Now, what we mean by depletion here in simple words is that we have already an existing channel. So here we can write a channel already exists, okay, between the source and what? And the drain, right? And the drain. And this is in fabrication. I mean, in the fabrication process, we have a channel between, we create a channel between the source and the drain. So this is the meaning of the depletion. So you can call it, since we already have a channel, some people or some references call it as normally what? On. Okay. Now, regarding the enhancement, there is no channel existing in the fabrication process, so we can say it as normally off. So you can say the enhancement normally off, or here you can call it also normally off. Okay. This is regarding the types of MOSFETs that we have in this course. Now, if you have any questions, please prepare your questions such that we can discuss all your doubts and questions during the live session. Now, let us start by we can start here, for example, by the N-MOSFET enhancement. And here we can see this is number 1, number 2, number 3, and number 4. Okay. Now, before we start, since we have here enough space, I can write I can represent each type by its symbol. Like number 1, the enhancement is like this. Okay. This is the enhancement, or some people write or draw it in this way. Good. Now, the depletion, or I can put it here, it looks like here, and we make or we create a thick line here. So this is 1 and this is 2. Now number 3, we can put it in this way. So the only difference, just put here a bubble. That means here we have P-type, or some references use this symbol. Regarding number 4, it will be like this. Okay. Good. So those are the circuit symbols for the types. Actually, some references use more other than those references, but those are the standard references. Okay, now let us start by number 1. We can say enhancement in MOSFET. Okay, in the enhancement in MOSFET, that means we have to have an in-channel type, or an in-channel between the source and the drain. So since we have to have a channel between the source and the drain, and this channel should be in type, this means this is the source and this is the drain here. Now how we fabricate all those regions, I'll explain it in the right time. Here we have drain, and again here it should be in type. Now regarding this material here we have p-type substrate here, substrate. Okay, and here of course we have the oxide, and then we deposit another layer, and this layer is metal, and in the new technology this layer, which is the metal, is replaced with highly doped polycrystalline, which has the properties of the metal and has better properties at the surface with the oxide. So we can see we have the following layers. We have here the gate, or here I will be writing VG, or the gate voltage. Okay, and we have, this is called VS, or source voltage. Okay, and then we have here at the drain VD, which is called what? The drain voltage. Okay, we have one more voltage, to be honest, which is called the bulk voltage, or the substrate voltage. Let me see here. This is called VB, or bulk voltage. And the bulk voltage all the time is grounded. That means this will be our reference. Good. Now if we go to the circuit symbol of the enhancement in MOSFET, as we know, it looks like this. It has how many terminals? This is the gate. So here you have VG. This is the drain. So you can say this is VD, and here we have what? The source, and you can say this is VS. And we have one more voltage here, VB, and VB again is the bulk voltage, and it should be grounded. Okay, now if the source and the bulk voltages are equal, I mean the bulk and the source are connected with each other, then you can say VB equals VS. And if both are grounded, you can say VB equals VS equals what here? 0 if they are grounded. Okay, good. Now our target here is to pull the electrons from where to where? From the source, okay, to the drain. And we know here it will be hard for the electrons to go from N, then P, then N. Why is that? Because last time when I told you, if we have here NP, then we have PN, the current will not flow in this way or in that way. So it will not flow in any direction, which means that the current will be 0. That means the device is normally off, as we wrote somewhere here. So this is why we call it here normally off. That means to turn the device on, we have to do something, which means we have to apply voltage at the gate voltage. Why is that? Because applying voltage at the gate voltage will either repel away the carriers or attract the carriers toward the source. Now, if we apply positive voltage at the gate, okay, if we apply positive voltage, okay, in this way the electrons which are here will be attracted to the surface. So the more the voltage we put, the more the carriers that we have around the surface. That means we end up with a channel, and right now the red one here is called in channel. Okay, this is why we call it in MOSFET. Now, why do you call it here enhancement? Because originally there was no any channel between the source and the drain. Now my question for you, what about if in the fabrication itself we create an in channel, I mean we dope one more in layer between the source and the drain? What will be that type? It will be depletion in MOSFET. Okay, so this is the only difference. Now in the depletion we call it normally on, because normally because we have a channel or we have a connection between the source and the drain, which means initially we have a connection, which means normally on. Now the second question, the electrons are negative, okay? Now to attract the electrons from the source to the drain, do you think we have to apply a positive voltage at the drain with respect to the source or negative voltage? Think about it. Now if we put positive voltage here, it will attract the electrons. That means there will be current. So my point is, take it as a rule. From now on, the enhancement in MOSFET here, VD should be more than VS. So here you can say VD should be greater than VS. Or you can say VD minus VS is greater than 0. Or you can say VDS greater than 0. So generally speaking, when you say VDS, it means VD minus VS. It means the voltage at the drain with respect to the source. This is the meaning of VDS, which means the voltage difference between the drain and the source. And this difference should be what? Positive. It should be greater than 0. Why is that? To attract the electrons through the channel. So please here, my students, if you have any questions about this point, please prepare to discuss it more during the live session. This is for the enhancement in MOSFET. Now, what will be the depletion in MOSFET? I'm sure you will be saying here the depletion will be here already a channel between the source and the drain. Okay, now before we go to the depletion, let me add one more point regarding the enhancement in MOSFET. If I draw VGS on the y-axis and the x-axis, and on the y-axis the drain current. So I'll be writing here, this is called gate to source voltage, and ID here is what? IDS. It would be better to write it in this way. IDS is the drain to source current, or you can say easily the drain current. Now IDS, it means the current from the drain to the source, which means the electrons are moving from the source to the drain. So if I go back here, right, the electrons are moving from the source to the drain, okay, which means the current IDS is positive, okay, it's not negative, because really the electrons are moving from the source to the drain. So this is why the current could be here or here or here or there. But since the electrons are moving from the source to the drain, IDS will be positive. That means it should be either here in this quarter or in this quarter, okay? Now the second question here, what about VGS? We agreed on that the voltage at the gate should be here what? Positive. Why is that? To make the device on. This is why the plot will not be here, it will be here. So this is why the plot will be in the first quarter. Good. Now let us think about it. When the gate to the source voltage, now you may say, why did we say the gate to source? Why didn't say the gate voltage? It will be okay, but all the time the voltage is measured with respect to something, because all the time the voltage terminals are two. One to measure the voltage, and the second is our reference. We take Vs as our what? Reference from now on. Okay, that means all the voltages are measured with respect to the source. When we say VDS, VGS, VBS, all the voltages are measured with respect to the source voltage. Okay, good. Now, when we apply 0 voltage at the gate, what do you think? What will be the current? There is no current. Why is that? Because the channel is not yet created. What about if we apply 0.1 volt, which is positive? Now, this could be that the 0.1 volt is not enough to create a channel. Okay, we have a little bit here electrons, but it's not yet created a full channel. So still the current will be 0. We will reach a point, for example here. After this point, the current starts increasing. So before that, the current is 0. Then the current increasing, it will be like this. Okay? Like this. One more time. So this is the relation between the drain current, or the drain to source current, if you like, it will be fine, to VGS. We call the voltage that makes a current in the device, we call this voltage what? VTH. Since we are talking about the N-type, you can say this is VTN. Because for the VTP, it will be again VTH. So either you say the threshold voltage, this is called the threshold voltage, which means the voltage at which the current starts, okay, to occur in the device. Or you can say the voltage needed, or you can say the gate to source voltage, okay, needed to create a channel in the MOSFET in this case, or in the enhancement in MOSFET. Okay, or you can define it in another way. It's the gate to source voltage needed to create a current in the MOSFET. Both are fine. Okay, good. This is for the enhancement. Now, what about the depletion in MOSFET? Number 2. Depletion in MOSFET. Okay, so that means here we'll be having an in channel at the end. So you can say this is the drain, this is the source, N-type, and this is again the source, this is the drain, and here we have the P-type substrate. Okay, here we have the oxide, as we mentioned earlier, and here we have the metal, or the highly doped polycrystalline. Okay, now the only difference between the depletion in MOSFET and the enhancement in MOSFET, in the fabrication we add an N-type, okay, or N-channel between the source and the drain. Now here I have a couple of questions. Okay, if this is the gate voltage VG, and here VS, the source voltage, and here we have VD, the drain voltage, and of course here we have what? The bulk voltage, or VB. Now my questions here, any positive voltage between the drain and the source makes a current, right? But how can we make the device off? Because at the end we will control the operation of the device. We want to make it on and off. Now it's normally on here because initially we have a channel between the drain and the source. And here we have many electrons, by the way. Why is that? Because the N channel means many electrons. Good. Now, do you think to make the device on here, do you think we should apply positive voltage or negative voltage? Let us think about it. If we apply positive voltage, okay, more current will come, more electrons will come here and the channel will be more. So this is why the device won't be off. To make the device off, what should be the charges here? Or what should be VG? If we apply negative voltage, okay, part of the electrons will be repelled away from the surface. That means there is an opportunity that the channel thickness will be 0. Okay. Again here, we want to plot the relation between, VGS here and ID. Now first of all, the electrons are moving from the source to the drain. This is the motion of the electrons. Okay, that means the conventional current will be from the drain to the source, which means IDS is positive. This is why the plot is here or is here. Okay, this IDS or ID, both will be fine. Good. Now, when we put VGS 0, I mean, we don't apply any charge. I think you can say, well, there is a current between the source and the drain if we apply positive voltage at the drain. Now, we should apply a negative voltage, okay? I mean, if we put VGS 0, there is a current. Good. So what about if we apply, let us say, minus 0.1, the current will be less. Minus 0.2, the current will be less. Minus 1 voltage at the gate, the current will be less. Why is that? Because the electrons will be repelled away from the surface. That means we will reach a point where the current is what? Is 0. So the plot looks like this. And then the current will be 0. Okay, this value or this point, we can call it VTH, which is again VTN. N means the N type. Now, keep in mind this value is negative, while the value here was what? Positive. So my point is the threshold voltage is positive for the N MOSFET enhancement, while it is negative for the N MOSFET depletion type. Good. I hope the explanation is not that difficult for all of you. Of course, if you have any questions, it will be my pleasure to elaborate on the two types. Now, number 3. Number 3 is what here? Enhancement P-type, okay? P MOSFET. Okay, now this means the channel that should be created should be what here? P-type. So we start by the N substrate, N-type substrate. And here we have the drain, here we have the source, here the drain, and this should be P-type, and here P-type, and we have the same oxide here and the same gate that we had before. Okay, so you can see this is the gate voltage VG, and this is the drain voltage VD, and this is what? The source voltage or VS, and of course this is the bulk voltage VB, sorry. Okay, good. Now this device is normally off. Why is that? Because initially there is no any connection between the source and the drain. This is why we call it normally off. Okay, now how can we create a P channel? I mean a channel that has a lot of positive charges. If we apply negative voltage here, just think about it, then the positive charges will be attracted toward the surface, right? And then a channel can be created at the surface, which means if we plot the drain here VGS and here IDS or ID. Now keep in mind here, this is the source, and this is a very important point, please don't forget it. And this is the drain. So the charges are moving, which are called here holes or positive charges. They are moving from the source to the drain. Since those are positive charges, this means the current is from the source to the drain, which means ISD is positive because from the source to the drain, or you can say IDS is what? Negative. Now here we have four options, either to draw IDS here or here or here or there. What do you think, in which quarter will be the current IDS? It will be in the third or in the fourth quarters. So that means the plot should be here or here. This number. Number two, what do you think VGS should be? Should it be positive or negative? To make the device on, it should be negative. So this is why the plot will be in the third quarter. So here 1, no, 2, no, 3, yes, and 4, no. Good. Now when we apply VGS 0, is there any current? I'm sure your answer will be no. There will be no current if the gate voltage is 0. We have to apply negative voltage. That negative voltage could be, for example, minus 1, minus 1.5, whatever you like. So here, when VGS is 0, the current will be 0. We have to apply negative voltage such that after that we have a current in the device. This voltage is VTH, the threshold voltage, and I will call it here what? VTP. And this VTP here is what? Is negative. So you can say the threshold voltage in the enhancement P MOSFET is negative. Okay? And take it as a rule in the P MOSFET, if this is the sample of the enhancement P MOSFET, this is VD and here V, or okay, I will write it in a different way. Okay, this is, I will be calling this is the source, and this is VD, and VS should be greater than VD. Why is that? What do you think? Is that true? Of course this is true. Why is that? Because VS should be more than VD to force the positive charges to move from the source to the drain. This is why VS greater than, or you can say VSD is greater than 0. And of course here the gate. Okay. Now to make the device on, one more time, VGS should be less than VTP to make this device what? On. Now if I go back again here, VGS should be greater than VTN, okay, to make this device on. So those are the differences between the three types, and the fourth one will be, of course, the depletion P MOSFET. So again here it means the channel that should be created will be P-type. Here the source and here the drain. P-type, P-type. This is the oxide, and this is of course the gate. And I'll be putting right now the voltages at each terminal. This is Vs, and this is Vg, and here Vd, and this is the bulk voltage Vb. And don't forget, here we have P-type substrate. N-type substrate, like what we wrote here, N-type substrate. Good. Now in the fabrication itself, we have already a P-type or a very thin layer, where this thin layer is P-type also. So this is P channel, and this is in the fabrication. Which means if you want to plot the relation between ID and VGS, first of all, we agreed on, since the holes, or since the positive charges are moving from the source to the drain, then the current would be from the source to the drain, which means IDS will be here what? Negative in the third or in the fourth quarter. Okay, now when VG is 0, when we don't apply any voltage at the gate, do we have any chance to have a current between the source and the drain? Yes, and this current will be negative, so I'll put it here. But how can we make the current here 0? What do you think? What should be the voltage applied at the gate? Think about it. I hope you thought about it. So we have to apply positive charge. Why is that? To repel the positive charges away from the surface, to make the device what? Off. So this is why we will reach a point where after that point the current will be 0. After that point the channel will be what? Depleted, or the channel will be removed. So when you apply 0.1, the current will be less. 0.2, the current will be again less and less. And here 0.1, 0.2, 0.3, the current will be less and less until you reach a point where the current is 0. Okay, and this is how the current look like this, and it will be 0. So this value is called VTH, and I'll call it here VT, what? VTP, and here VTP is positive. Okay, and keep in mind in the P-type all the time, Vs should be greater than Vd. This is in the P MOSFET, whether it's depletion or enhancement. As I wrote somewhere here, VSD should be what? Positive. Vs greater than Vd, or you can write it as VSD is greater than 0. So this is the comparison between the 4 types. I hope you enjoyed this presentation, and please prepare your questions such that we can again discuss them one more time during our live session. Thank you, my friends, one more time, and see you in the live session.